Today we are going to learn about optimizing linear regression with hyperparameter tuning. We'll explore how to effectively apply hyperparameter tuning techniques to enhance linear regression models using Scikit-learn, equipping you with the skills to optimize model performance and ensure robust predictions.
Welcome to our session on hyperparameter tuning. In the world of machine learning, hyperparameters are crucial elements that influence the training process and the performance of a model. Unlike model parameters which are learned from the data, hyperparameters are set before the learning process begins and guide the training dynamics. They can significantly impact the accuracy and generalization of the model. Today, we'll delve into what hyperparameters are, why they are essential, and how we can fine-tune them to optimize our models, particularly focusing on linear regression using Scikit-learn.
Hyperparameter tuning is critical for several reasons. First and foremost, it helps improve the accuracy of a model. By adjusting hyperparameters, we can find a configuration that minimizes error and maximizes predictive performance. Secondly, proper tuning can prevent overfitting, where a model performs well on training data but poorly on unseen data, and underfitting, where the model is too simplistic. Tuning also enhances computational efficiency. Some hyperparameters control the complexity and processing time of the model, and finding the right balance can save time and resources. Additionally, tuning allows us to customize the model for specific tasks, making it more robust and reliable in real-world applications.
GridSearchCV is a systematic approach to hyperparameter tuning in Scikit-learn. It performs an exhaustive search over specified parameter values for an estimator. The process involves defining a grid of hyperparameters and evaluating the model performance for each combination using cross-validation. This ensures that the best set of hyperparameters is selected based on the validation set performance, not just the training data. Scikit-learn's implementation of GridSearchCV makes this process convenient and straightforward. You define the parameter grid and the number of folds for cross-validation, and GridSearchCV handles the rest, fitting the model multiple times and scoring it against the validation data.
While GridSearchCV is thorough, it can be computationally expensive, especially with large parameter grids. RandomizedSearchCV offers an efficient alternative by randomly sampling from the hyperparameter space. Instead of trying every possible combination, it selects a fixed number of random configurations and evaluates them. This approach is not only faster but also often finds the optimal or near-optimal settings with less computational cost. Scikit-learn's RandomizedSearchCV allows you to specify the number of iterations, effectively balancing performance with computational efficiency. It's particularly useful when dealing with large datasets or models with numerous hyperparameters. Cross-validation is a pivotal technique in hyperparameter tuning, ensuring that the model generalizes well to unseen data. It works by splitting the dataset into several folds, using different subsets for training and validation in each iteration. This approach reduces the risk of overfitting since the model is validated on multiple data segments. Common strategies include k-fold cross-validation and stratified k-fold, which maintains class distribution across folds. When used with hyperparameter tuning methods like GridSearchCV or RandomizedSearchCV, cross-validation helps in selecting hyperparameters that consistently perform well across different data splits, ensuring a robust and reliable model. Once hyperparameter tuning is complete, the next step is selecting the best model based on the tuning results. This involves interpreting the outputs of GridSearchCV or RandomizedSearchCV, which provide detailed performance metrics for each hyperparameter configuration. Evaluating these metrics, such as accuracy, precision, recall, and F1 score, helps in identifying the most promising model. It's essential to understand the trade-offs between different models, such as simplicity versus accuracy, to make an informed choice. Once the optimal hyperparameters are selected, the final model can be applied to real-world data, ensuring robust predictions and performance. Let's now dive into a practical demonstration of tuning a linear regression model. We begin by setting up a basic linear regression model using Scikit-learn. The next step is defining a grid of hyperparameters to tune. For linear regression, these might include parameters such as fit_intercept and normalize. We then use GridSearchCV to perform the tuning, specifying the parameter grid and the number of cross-validation folds. Once the tuning is complete, we interpret the results to find the optimal parameter settings. Finally, we apply the tuned model to a test dataset to evaluate its performance, showcasing the impact of hyperparameter tuning on model accuracy and robustness. Evaluating the performance of a tuned model is essential to understand the improvements achieved through hyperparameter tuning. We assess various metrics such as mean squared error, R-squared, and prediction accuracy to quantify the model's performance. Comparing these metrics with those of the untuned model helps highlight the enhancements brought by tuning. Visualizing model predictions against actual values can provide insights into the model's reliability and areas where it may still need improvement. Reporting these findings clearly demonstrates the value of hyperparameter tuning, offering actionable insights into optimizing machine learning models for practical applications. In conclusion, hyperparameter tuning is a vital component of optimizing machine learning models, ensuring they perform at their best. We explored how GridSearchCV and RandomizedSearchCV serve as powerful tools for discovering the optimal hyperparameter configurations. Cross-validation plays a crucial role in this process, providing a robust framework for evaluating model performance. By tuning linear regression models, we can significantly enhance their accuracy, reliability, and applicability to real-world problems. We encourage you to apply these techniques in your projects, leveraging the power of hyperparameter tuning to build more efficient and effective predictive models.